All right, ladies and gentlemen, today is Wednesday, January 9th, and we're going to continue right along with Eureka Math, Module 3, Lesson 10. And today you're going to use everything you learned this week about number lines on Monday and equivalent fractions from yesterday, and you're going to use that to help you add mixed numbers. What's a mixed number? If we're going to be adding mixed numbers, we have to understand what mixed numbers even are. Paulina, what's a mixed number?
Fraction with a whole.
It's a number that has a fraction part and a whole number part. So can you give me an example of a mixed number?
1 and 2/3.
1 and 2/3. It has a whole number part and has a fraction part. That's a mixed number. It's mixed because it has two different things in it. Aradna, what's another mixed number? Two and 4/5. Yeah, it has a whole number part and a fraction part. That's a whole number. So today we're going to be learning how to add different whole mixed numbers. Okay? Let's go ahead and take a look at this first problem. 2 1/5 plus 1 1/2. Please write that down. As promised, it is a mixed number plus a mixed number. Yes? My first question for you then is how can we use the commutative property of addition to help us? Remember, when your parents commute to work, they're changing locations. They're changing their location from home to work. How could we use the commutative property of addition to help us? Well, we could think of 2 1/5 as 2 plus 1/5. Yes? And then we could think of 1 1/2 plus as 1 plus 1/2. And if we're adding those all together, is that the same thing as 2 plus 1/5 plus 1 plus 1/2?
Yes.
Okay, so how can we use the commutative property? Let's commute some of the numbers so that the whole numbers are together and then the fractions are next to each other. So that would be 2, oh my gosh, okay, 2 plus 1 plus 1/5 plus 1/2. Does that have the same value as what we had before? 2 1/5 plus 1 1/2?
Yes.
It sure does. Very nice. Okay, now that we know that, let's use what we know about the number line to help us. Go ahead and draw yourself a number line. Maybe make it go from 0 to 5. Now let's use what we learned on Monday and use our number line to help us figure out exactly where our number is going to be. Okay? If I start at 2, what do I have to add first? 1. If I do plus 1, what whole number will I be at on the number line? 3. Then I have to add what? 1/5. Okay. So let's imagine that's 1/5. You notice I didn't actually split it. I'm just kind of winging it. Thank you, Joseph. And then what do I have to add next? 1/2. Okay. So if I do that, my answer will be in between what two whole numbers? Because my answer is going to be right here, right? So it's going to be between what two whole numbers? 3 and 4. The number line is really good for helping us kind of estimate or wing it and see approximately where our final answer should be. So the number line tells us that our final answer will be in between 3 and 4. Another way to say that is 2 1/5 plus 1 1/2 will be greater than 3, but will be less than 4. Go ahead and write this inequality, this statement, this sentence in your notebook. So remember, we used the commutative property because we did to know that this is the same thing as 2 plus 1 plus 1/5 plus 1/2. Well, the whole number part is easy. We know 2 plus 1 is 3, right? So now we know this is the same thing as 3 plus 1/5 plus 1/2. Are we ready to add 1/5 and 1/2?
No.
Do they have like units? No. So we have to go through the same 3 steps we did yesterday to find the least common denominator, the LCD. We have to rewrite the equivalent fractions, and then we can add. Okay? So let's do that. Let's find the least common multiple of 5 and 2. Step 1, we have to skip count. Skip count by 5s. Let's go. 5, 10. Let's stop. Now let's skip count by 2s. Ready? Go. 2. What is the least common multiple between 5 and 2? 10. What should our least common denominator be then? 10. Okay, so let's talk about 1/5 first. We know that 1/5 is going to be multiplied by some version of 1 in order to get an equivalent fraction where the denominator is 10. What version of 1 do you recommend I multiply by? Everyone? 2/2. So therefore, 1/5 is equivalent to how many tenths? 2/10. Very nice. Let's do the same thing with 1/2. I can multiply 1/2 by some version of 1 to get an equivalent fraction whose denominator is 10. What version of 1 do you suggest I multiply by? Everyone? Therefore, 1/2 is equivalent to 5/10. Now that I know that, instead of doing 3 plus 1/5 plus 1/2, I can rewrite that as 3 plus what? 2/10 plus 5/10. Now could I do that math? If I have 2/10 and I add 5 more tenths, how many tenths do I have? What do you think is a very common fabulous fail 5th graders make? They might forget that there's the 3. Okay, so don't forget that. So my final answer then is 3 7/10. Now, if you go back and look at the inequality, we said that our final answer should be in between which two whole numbers? 3 and 4. Is 3 7/10 in between 3 and 4? So we feel good that that's correct. If I didn't write my 3 because I made the same fabulous fail that lots of people make and I get my answer as 7/10, is that between 3 and 4? Is that reasonable? In fact, if we look at the question, 2 1/5 plus 1 1/2, would 7/10 be a reasonable sum of those two numbers? So you always have to think for yourself, is my answer reasonable? Because I'm going to tell you right now, it's very easy to forget the whole number part because you're so focused on solving the fraction part, right? So you forget the quote-unquote easy part. But 2 1/5 plus 1 1/2, there's no way that could be 7/10, right? So if you write your answer and put the box around it as 7/10, an alarm should go off in your head, error, error, right? And you got to go back and see why that error happened. Does that make sense? Very good. So my final answer is 3 7/10. Sometimes the question might not even ask you to solve the answer. It might just want you to tell me what two whole numbers will fall on either side of the answer. Okay? That's what this question, when you see it like this, that's what it's asking. So let's think about that. If I have 3 plus 4 plus 1/2 plus 7/8, yes? We can use the commutative property to rewrite it like that. 3 plus 4 is going to be what number? 7, right? Okay, so we know that it's at least going to be 7. But we have to look at the fraction part just like we did in the previous problem to figure out if it's going to be in between 7 and 8 or it's going to go past 8 and be between 8 and 9. So let's think. 1/2, okay, that's exactly half. What would I have to add to 1/2 to make it go to to a whole? 1/2. What about 7/8? Is that bigger or smaller than 1/2? So I know, is 1/2 plus 7/8, is that going to be less than 1 or bigger than 1? It's going to be bigger than 1. Okay, so what two whole numbers then will this answer be between? Is it going to be 7 and 8 or 8 and 9? 8 and 9, very good. So that would be the final answer that you have to write in the book. Does that make sense? Very good.